Okay, hi students. In this video we'll see the usage of the switches. So let us start by taking a breadboard. So let us take this slide switch. It has got 3 terminals. So if you see here, so one is common terminal, other is terminal 1, next is terminal 2. Depending on this slide position, this common is connected to terminal 1 or terminal 2. So let us connect a battery, 2 terminals of the battery to one to terminal 1, terminal 2, and try to slide this switch position, then try to see what is the voltage. So let me take a battery which is of 9 volts. Let me connect positive of the battery to this plus and this negative to this ground. Let me have the convention black as ground and red as 9 volts, and let us connect one of the terminal to this VCC, and that is 9 volt, other terminal to ground. Let me make it this, and this is my common terminal. So let us use a multimeter to measure the voltage. So this is my multimeter. I will connect the negative to ground, and this I'll connect it to this terminal. Let me use a different color for this, maybe orange. Now if I run now, depending on this slide position, now it's connected to terminal 1. So since terminal 1 is connected to ground, you're getting 0 volt. If I just click on to this, so now you can see the slide switch has moved to terminal 2. Since terminal 2 is connected to 9 volt, you're getting 9. So this is exactly how it works. So this can be slide to terminal 1 or terminal 2, so the corresponding voltage will come over there. So this is also called as toggle switch. So if you can see here, this is how it toggles. You have a toggle switch. So this is terminal 1, terminal 2, this is common, this can be 9 volt, this is grounded. This will be either 9 volt or ground, depending on whether it is there in terminal 1 or terminal 2. If it is connected to terminal 2, it will be 0 volt. If it is connected to terminal 1, it will be 9 volts. So in the lab you can think of using such type of toggle switches, where you have 3 terminals here, and depending on the position of this switch, this common terminal will get terminal 1 voltage or terminal 2 voltage. So depending on where this is connected, this is one simple switch. The other switch you can think of is a push button switch. See, now this is a push button switch. You can take this switch here, and you can, this is how it exactly, push button switch is something like this. It has got 4 terminals, but only one switch is there. This is that push switch. So this is, maybe you can see what is that naming. So this is 1B, this is 1A. So this is 1B, 1A, this is 2B, 2A. So this is how the switch position is. So this is my push button switch. So now I can connect this to 9 volt, and this can be connected to ground through a 1K resistor. Now I can able to measure the voltage here. So I can measure the voltage here, whether I press or not. If I don't press, it is 9 volt. Even if I press, this is always 9 volt. Whereas here, if I say this is Vy, now if I don't press, it is 0 volt. If I press, it is 9 volt. Whatever is the voltage. Okay, why it is 0 volt when you don't press? Because there is no current going here, so that's why drop is 0. When I press, the entire, okay, now this is shorted here, 9 volts comes here, so this is 9 volts. So this is 9 volts whether you press or don't press, whereas here if you press it is 9 volt, if you don't press it is 0. The same voltage will be available here. It will be 0 or 9 volt, it will be always 9 volts. So there is no change in the voltage at 1A and 1B. 2A, 2B will be same, whereas depending on the position of the switch, whether you press or don't press, the voltage will change. So if I don't press, this is 0. If I press, this is 9. So here the voltage is always 9. Let us do that here. So what I'll do, I will connect this to 9 volt. Let me make it red, and let me use a resistor over here, and let me rotate that. Let me move it so that it's properly connected. This end should go to ground. Let me connect that black in color. Let me use, of course I can take out this switch totally, which may confuse you. Okay, I would have retained that multimeter. Okay, let me take, so this is a multimeter here. Let me take another multimeter. Let me copy this, paste it here, maybe one more here, maybe one more here. Let us see the voltages at different points, because there are 4 positions. So what I'll do, I will connect the negative of this and connect this to this, and this negative, and this negative are grounded, whereas the positive of this, let me connect it to this, the positive of this, let me connect it to this. So let me change this color to some yellow, this also to yellow, maybe this, let us connect this here, let it be different orange, let us connect this to this. Now these two voltmeters should show same voltage, and these two should show same voltage. So now whether I press or not, this should always show 9 volt. When I press, this should show 9. When I don't press, this should show 0. Let me start. You can see this is showing 9 volts, 9 volts. This is showing 0 volt, 0 volt, because you didn't press it. The moment I press, this still remains as 9. So this 0 will become 9. See now, 8.99. I'll remove this. Of course, when I don't press, this voltage will not change, because you are actually measuring the supply voltage. So this will not change. So that's exactly the thing here. The voltage here is 9 volt, whether you press or don't press. When you press both, of course here it is 9, here also it is 9. When you don't press, it is 0. See now, it's running. I'm not pressed, that's why it is 0. The moment I press, it is 9 volts. This is, of course, 8.9, because there is a drop happening in the resistor. Okay, some current starts flowing, and then this is delivering some voltage. Okay, delivering some current to this, so that voltage slightly reduces. So now this is how a battery, how a switch will work. So what all switches you have, so that's it. Now let us see how do we read some analog voltage into the Arduino. So I have some programs, you can have a look at them. So this is now this will read the port value and then display it on the let us see what it is doing. So this is a very simple potentiometer. One end of the potentiometer is connected to it is connected to 5 volt of the Arduino, other end is connected to ground. The center point is connected to A0, that is the analog input, and we are writing a code where it is actually reading the A0 value into the port value, and you are actually finding its whatever port value is, it will be the decimal equivalent of the digital output that is coming from the analog value. So there is a A to D converter. So this is actually this pot value will going to hold the decimal equivalent of this analog number that digitized analog number, and that is now converted to the analog voltage. Pot value multiplied by this is conversion from the decimal to the analog value. So this is what's happening here. Now I can run the program. We will just see in detail what happens. See now, this is of course the analog decimal number and the corresponding analog voltage. See now, so this is 205 is the decimal number corresponding voltage, and here it is 900 is the decimal number, 4.39 is the analog voltage, and maximum you have 1023, you have 5 volts. This is decimal equivalent, and this is the analog voltage. So that's what is this. Exactly why this is 430, how that is converted, what is this number, that is you have a number, this 5 divided by 1024. Okay, these are all actually the let us try to understand what it is. Actually what happens is inside the Arduino, okay, you have, this is A0 to A5 is there, so there is a ADC, analog to digital converter. So there is a analog to digital converter. So this is actually a 10-bit converter. This is a 10-bit converter, meaning the input voltage can vary from 0 to 5 volt, whereas this 10 digit number you have, okay, B9, B8, B7, okay, bit number 6, bit number 5, bit number 4, bit number 3, bit number 2, bit number 1, bit number 0. So 0, 0, 0, 0, all 0 to all 1 is, all 0 corresponds to 0 volt, all 1 corresponds to 5 volt. So since you have a 10-bit number, so what is 2 power, okay, now this is actually 10-bit. So if you actually find out what is, where is that, this one can see. Okay, this is 2 power you know that 2 power n, so 2 power 3 is 8. So now you are looking at what number? You are looking at 2 to the power of 10. So now since there are 10 bits, it is 2 power 10 is 1024. When all the bits are 1, you will get it as 1023, meaning including all zeros to all ones, there are, starting from all zeros to all, okay, when I say all zeros, all 10 bits are zeros and all 10 bits are 1, the total number of combinations are 1024. Assume that it's like, okay, for 5 volt it is 1023. Suppose if you just take an example here, so you have 430 here, no, this is 430. I am looking at what is this x value, what is that? You have this, okay, it's actually 2.1 volt we are getting, correct? Let me see how to get this. So what is this? Of course, we from the calculation from the Arduino we are getting it as 2.1. Let us find out how much is this value. So now so if you actually find out this, so what is x now? Is x, is it not equal to 5 into 430 divided by 1023. What is this? You have 5 into 430 divided by 1023. See now, is it not 2.101? That's what you have here. That's what you have here. So this, okay, let me just make it. Okay, we usually take okay, it is written as 1024 because 5 divided by 1024 happens to be 1 LSB. 1 LSB. So what is this 1 LSB? 1 LSB is nothing but least significant. Suppose if your bit changes by 1 bit. Okay, now if you see here, suppose if this is your least significant bit. If this value change, assume that you have all zeros and remaining all bits are 0, but this is 1. But this is 1. So for whenever there is a change happens in the least significant bit, what is the corresponding input voltage you are going to have? So it is given by, it is set as 1 LSB. 1 LSB is always equal to V reference divided by 2 power n. So what is 1 LSB? It is 5 volt divided by, since it is 10 bits, it is 2 power 10, which is nothing but 5 by 1024. If the decimal number is 320, then what is the analog value? It is 320 decimal number multiplied by 1 LSB. Suppose if it is 638, so what is its analog value? It is 1 LSB. What is this 1 LSB? This 1 LSB is 5 by 1024. So that's what we have here. See now, you have this as number 430. Let me just make it to some other number. Oh, sorry, this is moved. Suppose if I, now let me run this. If I move it, see now, what is the decimal number? You can see it is 434. It is actually 434, sorry, 634 multiplied by 5 divided by 1024 is the number which is 3.095. It is 3.095, which is approximated as 3.1 volt. Which is approximated as 3.1 volt. That's how the value is coming as. So what we are trying to do here is, so whatever value that you read from A0, it will be in the decimal form of your analog voltage. So of course you have this analog voltage which is 3.1 volt. This 3.1 volt is first converted to digitization has happened. What is that? Corresponding to 3.1 volt. So you have so many ones and zeros corresponding to 638 decimal number will be there. So whenever you do analog read A0, this digital number is converted to decimal and that value will be coming at A0. So that will be read on to that port value what is specified here. So this port value actually gets the decimal equivalent of the digital value. So that will be sitting over there. If you want to know the analog value, you simply multiply that decimal number with the LSB, which is nothing but 5 volt divided by 1024. This 1024 is coming because of 2 power n, which is 2 power 10, because their Arduino has a 10-bit ADC, A to D converter. Now assume that you have to write the same value onto your analog out. In such case, what to do? You can see here, so I think I have one such value where you are reading the analog value and writing the similar analog value outside. For that, I think you have this somewhere. Okay, port value, read display. Okay, and then analog in, analog out. Okay, this is 3 port digital values. This is analog in, analog out. You see what happens here. You are reading the analog value and you are writing the analog value onto this. See, now this is what you are doing. Now when you say analog read A0, this will be holding the decimal equivalent of that digital number, which is a 10-bit digital number. One thing you have to be very careful, this Arduino has got a 8-bit DAC. If I just come here, as we know, this Arduino has a ADC. Similar to this has got a DAC, digital to analog converter, which will give a analog output voltage in the form of PW. So when you are having a DAC, assume that you have read from a 10-bit ADC. This is a 8-bit DAC. So you are reading it from 10-bit ADC, but you are writing it to 8-bit DAC. Why it is 8-bit DAC? Because that's what is the specification of your Arduino. So when you are reading from 10-bit, so this is like it has got 10 bits. So this is B0 to B9. While writing, it has to be written, because digital input you have to write. So you have to write B0 to B7 only. So this B8 and B9 bit are not there for your input of DAC. So when you don't have these 2 bits, suppose that you are reading actually 1023. When you are reading 1023, how do you write this onto, how do you fit it onto hardly 8 bits? So what you have to do, so assume that your read is 630. So 630 will not going to fit into this 8-bit number. So you divide it by, if you divide by 2, this will be made 9-bit. If you divide by 4, this is going to fit into 8 bits. So whenever you read any value onto your onto your Arduino, if you want to transfer the same thing onto output, analog output, you have to divide it by 4. You have to divide by 4 because this is a 4-bit DAC. The input is 10-bit ADC. It reads 10-bit. While writing it onto a 8-bit DAC, it has to be divided by 4. So that's why it is divided by 4. Where is this? Let me just check this. See, can you see this is divided by 4? Whatever port value you will get when you divide this by 4, whatever port value, that is decimal value, if you divide by 4 and then write it onto this DC motor pin, so you will be exactly getting same voltage. That you can check out here. So what I'll do is, let me have 2 multimeters. Where is this? You have one multimeter here. Let me take one more multimeter here. Let me take out this, delete. I'll ground this. Let me ground this again. Where is the ground? Okay, let me put it here. Let me make it black. Let me make this also black. Let me measure this input voltage that is fed to this. Okay, let me make a different color, maybe orange. This is how the orange is going, and let me measure the voltage from this to this. This is my analog out. Now these two voltage should be same because you have divided in the code. So as per the pot position, the voltages will be same. So I'm running. Oh, sorry. This is not the VCC. I should connect it to this. Sorry. Okay, let me select this. Take it to this. Okay, let me connect it here. Oh, let me. Okay, this again. I'll connect it from here. Okay, this is a normal wire. Okay, fine. Now I'm measuring the analog input voltage, and I'm measuring the analog out voltage. See here. Okay, why it is not same is because this is actually driving. So if you want to, of course, this is not the same. So let me just show you that. Let me take out this drive. If I take out this drive and if I run, then you can see it is perfectly same. You can see it's almost same. Why that was not coming is because that motor was actually drawing some current. There was some drop. So now if you change the position, see here, it is 3, almost there. That divide by 4, you may lose one position, or it's almost the same. Because when the red value is an odd number, assume that it is 343. When you divide by 4, so that will be plus or minus 1 will happen. So because of which there will be slight variation. The moment you what is that? Okay, let me stop this and then redo. If I do this and if I run, it won't match. So the reason is this is loading. I hope you got the point. It is 4.2.6. There it is 1.47 because it is loading. If you want to avoid this loading, you may have to use a buffer so that the voltages will be same. If you want to still see the same voltage over here, it's better you delete this and then run. See, now the voltages are same. Because this is because what you actually getting is a square wave of different pulse widths, so that's why it looks so. That's why it is coming like a variation one. So that's it. Like analog read, analog write, analog how do you manipulate the value when you read it inside. So what is the actual analog voltage when you actually read? It is nothing but decimal number multiplied by 1 LSB, where 1 LSB is 5 divided by 1024. Thank you.